Mealyform, formerly Pullform,
makes possible the net shape forming of large aerospace parts for both military and commercial applications. Well, the future is here. Introducing the next generation in metals manufacturing technology, Pullform, a proven process that can fabricate components faster than machining, more accurate than conventional forging, and still maintain lower costs. The Pullform process squeezes material in a progressive and sequential motion that gradually compresses material to completely fill a female die cavity of a desired shape. A Pullform die consists of a lower female half and an upper male half. The male portion is made up of segments, where each segment can move independent of each other. The Pullform process fabricates structural parts with minimum material waste, less flow time, and enhances the structural integrity of net-shaped parts. Pullform technology created this part, weighing 0.95 pounds, from a blank weighing only 1.06 pounds, resulting in 3.8% scrap. If this same part were machined from thick plate stock, 5.12 pounds of material is required, resulting in 81.4% scrap.
The goal of this project was to evolve the manufacturing of intricate aircraft parts, which have relied heavily on forgings for many decades. The vision for the new method was to create a system that would be less expensive to construct, that would produce parts more quickly, and that would reduce the amount of machining required to produce finished aircraft parts. As shown briefly in the introduction, we developed Mealyform, where the material is formed at a controlled strain rate. Our process uses a segmented die to move the material progressively. This reduces the force required in the forming and provides for material flow that is not detrimental to the structure and metallurgical properties of the material. The resulting part is net shape, greatly reducing the machining required, with very significant savings of both material and time. The development of the Mealyform process was advanced through funding from a DARPA Small Business Industrial Research Grant. The work on the SBIR grant was performed jointly with Pratt & Whitney's research department. We concentrated on half-hollow turbine blades, a very intricate and expensive operation. According to Pratt & Whitney, the buy-to-fly ratio with their then-current method was 10-to-1. After analyzing the results of the work we performed using Mealyform, Pratt & Whitney projected the buy-to-fly weight would be approximately 1.2-to-1. Traditionally, these half-hollow fan blades required diffusion bonding of both halves, followed with a twisting procedure to achieve final shape. It was reported that a large percentage of these turbine blades failed at the diffusion bonded surface. Using Mealyform, we were able to form half-hollow blades with a twist already included to minimize strain after bonding. This chart shows a part for a Sumitomo sports car. It is the upper and lower control arms for a lightweight aluminum car. Sumitomo required 3 forging dies and 1 stamping die to create the part. They started with 10 pounds of aluminum, and the finished part weighed only 4 pounds. Using the Mealyform press, it was possible to make the part to net shape with only 1 die. A significant test for this project was Sumitomo requested documentation of the flow characteristics of the material during forming. To do this test, we used colored wax layers to show how the wax material flowed as it was pressed by the die segments. The chart was produced by Sumitomo engineers. As you see, the material flowed evenly to fill the entire die cavity. These parts were suggested by General Dynamics, who build the large barrel sections for solid propellant missiles. The most effective design was an isogrid that presented sufficient stiffness. General Dynamics requested Mealyform attempt to form an identical isogrid used on the barrel sections. These are the results. The volume of this material blank was expanded 4 times the volumetric space of this Mealyform specimen. General Dynamics prepared a proprietary report showing the grain flow in the vertical and sidewalls of the Mealyform parts. A very significant case study shows how Mealyform can revolutionize the manufacturing of large aircraft parts. The 747 wing beam shown on screen was forged on a 50,000-ton Wyman Gordon press. After forging, the weight of the beam was 3,750 pounds, After machining, the finished weight was 825 pounds. This resulted in 78% material scrap. Machining took 213 hours. The Wyman-Gordon process required a total of 6 operations: stock, heating, cog, and then 3 forming dies. The next chart shows the procedure for making the Boeing 747 wing beam from flat stock to finished part in a mealy-form segmented die, and processing is shown in the chart. The time in the mealy-form press will be approximately 2.5 hours. No machining will be required beyond the removal of flash. The part will be net shape. Alcoa was the leader in making large forged parts considered to be precision. It is very difficult to make precision parts with multiple flanges using conventional forging machines. A mealy-form press can produce parts of varying lengths, varying flange dimensions, and with negative or positive draft angles. Working with Alcoa years ago, we received drawings of several large aircraft parts to be evaluated for manufacturing costs, including die costs. The chart shows 3 such parts and also an open view of one of the mealy-form die designs used to make such parts. We prepared a summary report on the costs and feasibility for Alcoa. All the parts you see here were made on the prototype mealy-form press. All parts are net shape with a surface finish of RMS 32. They are designed with a flash to ensure complete filling of the part die. We have developed the technology for fabricating net shape forgings. A patent is pending on a production mealy-form press design capable of forging net shape parts of expanded lengths and widths. We have worked with each of these internationally known manufacturers to successfully create net shape parts to their specifications and have fully documented our results. The mealy-form process is applicable to many manufacturing industries, creating parts of nearly any size, using multiple materials, and doing so efficiently and less expensively than current manufacturing processes. Since the patent process is nearly complete, we are ready to collaborate with a larger manufacturer to make an operational mealy-form press capable of revolutionizing the forging business. Please contact us for more information.